Okay, let's dive right into this. Today, we're exploring a massive paradigm shift in physics, one that is entirely based on the groundbreaking research of Dr. Nethawet Wachara-Kuldeelok. And what this research reveals is absolutely mind-bending. It turns out the universe doesn't just decay into disorder, it actually uses chaos as a building block. We are moving far away from the old idea of a simple linear universe and stepping straight into the wild and incredible era of non-equilibrium thermodynamics.
So think about it. This brings up the ultimate puzzle, right? The fundamental clash between the physical laws as they're written on paper and what we actually experience as human beings. The classical physics equations from absolute giants like Galileo, Newton, and Einstein, they all operate under the assumption that space-time is a linear structure. The math is completely symmetric under time reversal, meaning if you run the clock backward in their equations, the physics still works perfectly. But in reality, we know that just isn't true. Hot water cools down, wood burns into ash, we get older. For us, time only moves forward.
There is a profound disconnect happening here. In classical mechanics, time and space are treated as just mere coordinates. If you swap positive time for negative time, the equations literally do not care. But our everyday world is an irreversible, nonlinear reality. We see turbulent fluid dynamics, biological evolution, the expansion of the cosmos itself. The problem is, linear systems completely fail to generate an arrow of time because they just don't have the mathematical tools to account for irreversible changes.
And this right here is a crucial breaking point for classical science. Look, linear models are perfectly fine if you're dealing with minor, tiny disturbances near a state of equilibrium, but they completely fall apart when you try to capture the real magic of the universe. I'm talking about how novel, highly ordered structures just emerge from totally chaotic conditions. Significant transformations in nature usually come from bifurcations, those critical forks in the road where a system's behavior completely changes, and from turbulence. In those chaotic moments, the old linear spacetime frameworks just can't explain what's going on. To solve this mystery, we look to the Nobel Prize-winning chemist Ilya Prigogine. Back in 1977, he introduced a total game-changer, the concept of dissipative structures. He proved that open systems operating far, far away from thermodynamic equilibrium don't just decay into a chaotic mess. Instead, when you pump flows of matter and energy through them, they self-organize. They literally use that energy flow to build complex structures. We see this all over nature. It's how tornadoes form, it's how forest fires spread, even how urban cities grow. Order is quite literally emerging from disorder.
So what does this all mean for us? Well, we have to completely rethink the entropy curse. For decades, physicists viewed entropy as just the universe slowly winding down into uselessness, something we always had to fight to minimize. But in these smart, far from equilibrium systems, the goal is totally different. It's not about minimizing loss anymore. The focus shifts to strategically controlling exactly how that entropy is discharged. And why does that matter? Because suddenly, entropy isn't a curse of decay at all. It's the actual engine of evolution. Okay, but how does this shift actually work in modern engineering? I mean, it's one thing to talk about tornadoes and grand cosmic theories, but how do we go from just trying to minimize entropy to actively controlling it in the real world? The secret sauce here is a phenomenon called resonant dissipation. Instead of stubbornly fighting the chaos, engineers apply external influences, like electromagnetic waves. It's kind of like pushing a swing at the exact right moment. By perfectly tuning those inputs to a system's own natural frequency, we can systematically guide the flow of entropy away from the core and out toward the boundaries. We're navigating the entropy flow, rather than just futilely trying to push back against it. To really wrap your head around the staggering scale of this kind of engineering, we just need to think about magnetically confined plasma fusion reactors. We are talking about environments operating at over 150 million degrees Celsius. That is an extreme level of non-equilibrium, and at those temperatures, the old physics rulebook goes completely out the window. At that insane state of non-equilibrium, trying to just suppress turbulence is physically impossible. Conventional engineering tries to eliminate instability directly, and that just doesn't work here. Instead, modern engineers use wave-particle resonance to create a dissipative boundary layer. They actually embrace the instability. They use resonance to efficiently channel that inevitable entropy increase outward. And doing this keeps the core perfectly stable. It prevents a total catastrophic collapse of the plasma, all by strategically managing the flow of chaos instead of trying to trap it. Which brings us to a super fascinating revelation about how we measure reality itself. Now, while spatial coordinates and absolute time might be completely relative and depend on the observer, Temperature and its gradient are not. They are the most objective, information-rich variables we have for decoding how any system evolves across literally any scale. Temperature reflects the distribution of kinetic energy, from the tiniest particles all the way up to sprawling galaxies. Any major change in a system inevitably leaves a trace in its temperature profile. And this is exactly why looking at the cosmic microwave background is so profound. By analyzing incredibly tiny thermal fluctuations, we're talking just 1 in 100,000, scientists can pull far more accurate, detailed information about the early universe than they ever could by just charting stellar positions. The temperature is basically an indelible memory of the universe's entire evolution. Because of this, diagnostics in physics are undergoing a massive shift. The old way of doing things was completely obsessed with the present. It constantly asked, what is happening at this exact specific time and spatial coordinate? But modern diagnostics, especially in complex places like fusion reactors, are looking ahead. Modern physics asks, how fast is the heat changing at the edge? By watching that thermal gradient, physicists can now predict and control system bifurcations, basically heading off huge instabilities long before widespread failure ever happens. So we've seen exactly how this works in a high-tech fusion reactor right here on Earth. But what happens if we take these exact same rules of non-equilibrium thermodynamics and scale them up to the very edges of the universe? Well, when we scale up to the cosmos, two colossal ideas collide. First, you have Roger Penrose's whale curvature hypothesis. He argues that right at the Big Bang, gravitational entropy was at its absolute minimum. And that implies our entire universe functions as one colossal, open, dissipative structure that gradually builds complex things, like galaxies and stars, by increasing gravitational entropy. On the flip side, we have Stephen Hawking's black hole information paradox. Hawking originally showed that black holes emit a thermal spectrum, which challenged the rule that quantum information can't be destroyed. But today, contemporary holographic principles reveal that a black hole's entropy is actually a quantity of information that is precisely stored and encoded on its surface boundary, the event horizon. Which leads us to a profound realization that totally changes how we view the cosmic scales. Entropy isn't just a measure of disorder or decay or universal trash. It is a vital quantity of encoded information stored right on the boundaries of systems. And temperature? Well, temperature turns out to be the universal language that nature uses to balance and communicate all that information. Synthesizing all of this incredible source material, we really land on 3 massive takeaways that form this entire new paradigm in physics. First, time is entropy production. The arrow of time is the direct consequence of irreversible entropy discharge. Second, resonance is the key to navigation. Aligning with the system's natural rhythms lets us actually guide entropy rather than fight a losing battle against it. And third, temperature is the code of reality. Measuring temperature profiles is the absolute most powerful tool we have for both deciphering the deep past and controlling the advanced energy systems of our future. Ultimately, what this explainer shows is that 21st century science is decisively moving on from equilibrium engineering. You know, that futile goal of trying to keep systems perfectly stable and unchanging forever. Instead, we are fully embracing controlled evolution. Nature doesn't follow some rigid deterministic path. It walks right along the surface of thermodynamic potential. And modern physicists, they're learning to read that surface. We are now actively modulating disequilibrium, we're harnessing chaos, and we are using the flow of entropy to evolve and stabilize incredibly complex systems. We aren't just victims of universal decay anymore. We are navigators of a dynamic, evolving cosmos. So I want to leave you with this final thought to ponder. If chaos, instability, and entropy are actually the grand builders of our reality, how will humanity harness them next? Thanks so much for joining me on this deep dive. Stay curious, and I'll see you in the next explainer.